Welcome to Chapter 1, Section 5 of today's presentation. So we're still talking about equations. We're going to move forward a little bit with our understanding. So we worked on simplifying expressions. We solved equations with one variable. Now we're going to practice solving equations with two variables and improve our skills a little bit on those equations. So with the same vocabulary we talked about last time, we're going to utilize this information to help understand more complicated equations that might have more than one unknown variable. So we're going to start with a standardized test example. We'll call this one example 2 for today. So we have all of these numbers that we have to work with. We know that they're equal to our variable w. So we don't have to solve for w, it's already there. But what does w equal? Well, we have to simplify this whole expression here. So if we do what's in parentheses, we can work through this. So in the top, I know that this is 3 times the quantity, 6 plus 4. And I know 6 plus 4 is 10. So if I rewrite the numerator, this is 3 times what I know 6 plus 4 is, that is 10. We have 3 times 10 on top. And if I just ignore the denominator for now, I also know 3 times 10 is going to give me 30. So I should get 30 on top. Good. Now if we go back to our denominator, we can simplify what's down here. So we get 21 minus something. So I'm going to just carry over the 21 minus. And in here, we're going to get 10 minus 6, which is 4. And I know 4 squared is 4 times 4, which is 16. So this is 21 minus 16. If we simplify the denominator one more time, 21, take away 16, gives me a total of 5 for our denominator. Now, 30 over 5, this is, of course, a valid answer, but it's not the best answer because we can simplify this. 30 divided by 5 is a whole number, and that whole number is 6. So of our available options, we should have letter choice D. So the variable w is 6. That's what we know from that example when we work through that equation. Again, that's just a one variable equation. We can work on more complicated ones as we move forward. Here's example 3. We want to solve this expression. It's equal to 12. We see we have one variable f right here. We need to know what is f equal of these available options. So let's simplify what's in here. If we know 4 squared is 16, and 16 minus 6 is 10. So this whole thing in here is really just 10. Plus f minus 9 will equal 12. Good. Now I know I can switch the order of these things around. So I can say 10 minus 9 plus f equals 12, and that would be fine too. And I know that 10 minus 9 is just 1. So I can rewrite this side of the equation as just f plus 1, because 10 minus 9 is just 1. And if our variable plus 1 equals 12, well, what does this sum number have to be for this to be true? Well, if you're not sure, you can subtract 1 from both sides. So if you took away 1 from both sides, you would get f on the left. And f would be equal to 12 minus 1, which is 11. So of these choices, our answer should be C. The variable f has to equal 11 in this equation. So let's move forward. 3b tells us to solve this expression for the value of n. So what does n equal in this solution? So notice It could be possible that there's no solution. It could be possible that it's all real numbers. So we have to work through this and see what we get. So if I just simplify a little bit here, I know 7 squared is going to be 49. And 49 minus 29 is just 20. So this side simplified one step would be 2n minus 20. So I'll write that down here. Two n minus 20. Good. So one step on the left. Now let's work on making the right a little bit easier to deal with. I know 2 to the third power is 8. So parenthesis 8 minus 3 times 2 is 6. We have times n and plus 29. Now we can simplify one more step. So this side I can't do anything else with on the left right now. So I'll just leave that. But what about the right side? This n can be distributed to whatever this is in here. And I know 8 minus 6 is the same thing as 2. So I can write this as 2 times n plus 29. Now the left side we have the same thing, 2n minus 20. So we've got 2n minus 20 equals 2n plus 29. Now if we try to move our n's around, let's see what happens. So I'd want to get them both on the same side of the equation. The only way you could do that is to subtract 2n from both sides. And if I take away 2n from both sides, if I did a minus 2n here, and a minus 2n here, these actually cancel out. 2n's cancel out, and we would get negative 20 on the left equals 29. Now remember from last time we talked about if your variable disappears and you're left with a statement, we need to check and see if that statement is true or false. If the statement is true, all real numbers would work for your equation. If the statement is a lie, if it's false, we know that there is no possible number we could plug in to make this work. So in this case, negative 20 equals 29, that is not true. That is a false statement. And since this is a lie, we know that there could be no solution to this problem. There is no number for n that you could put in that would make negative 20 equal 29. So for this one, it's one of those special cases where there is no solution to our example. So for 3b, we've got no solution. There's no possible number that would make this whole statement true. Moving on to example 4. We want to solve for d in this equation. So d can be one of these 4 things. Now we have to pay close attention. There might be any real number scenario here, or it could be a no solution like last time. So let's see if we can simplify this and understand it. So if I just simplify one step here, let's change our pen color. Let's go blue. So I know 4 times 4 is 16. Times 4 again is 64. So I'll get a 64 for 4/3. We get plus 6d. 6 times d. And minus, I know 2 times 8 is 16. So I'll simplify that part to 16. That's going to be equal to 3 squared is 9. 9 minus 1 gives me 8. And 8 minus 2 gives me 6. So that is 6 times our variable d. So this is 6d plus 48. Good, so 64 plus 6d minus 16 equals 6d plus 48. Excuse me, this is an 8. Okay, so we've got 64 minus 16. That's just a number. I can simplify that. So 64 take away 16. If I took away 10, that would give me 54. And if I took away 6 more, that would give me 48. So this is 6D plus 48 on the left. And if we look at what we have on the right, we have the exact same thing, 6D plus 48, 6D plus 48. We don't have to change anything there. So if I rewrite that just one more time, just for the sake of symmetry, we can see here we've got the same variable, the same numbers on both sides of our equation. We talked about this. If you have some term equaling the exact same term, it's the exact same on both sides, then any real number that we plug in for D will work. If D is 0, we'd have 48 equals 48. If D was 1, we'd have 54 equals 54. No matter what number we plug in, this will always be a true statement. So any real number will work because we see the same thing on both sides. So for example, 4, for today, the answer is C. Any real number will make that expression work. Example 5. So we've got a couple sentences here we need to jot down. So as you're jotting that down, we'll work through these examples. So we're going to need to circle some things that are important. We have an online catalog. They have a price for a jacket that's $42. So $42 is important. They also charge $9.25 for shipping per order. So for shipping per order, $9.25. We need to write and solve an equation. So we need an equation and find the total cost of 6 jackets. We're going to order 6 jackets and find out how much that costs. So since we know the things that are important, we can work through this. 42, 925, we've got 6 jackets. Okay, so I know that the price of a jacket is 42. We're doing 6 of those. And there's a $9.25 fee for shipping per order. So this $9.25 fee will just be one added fee that's added to our whole total. So that should be a plus $9.25 by itself. And if we look at the options, A and D both have $9.25 by itself. Like here, you see plus $9.25. That's a one-time fee we'll pay. So those two look okay, but these two don't have $9.25 by itself. So we know B and C have to be out. Now we also know that the price for a jacket is $42, but we're buying 6 of them. In other words, it'll be $42 times some variable that represents the number of jackets that we buy. So 42 times some variable, we can call it J for the number of jackets. 42J will be how much it costs to buy any number of jackets. So if we look at our available options, only D has 42 times J, the number of jackets. So A is also out. And if we want to double check, we can see here that this makes sense. The total cost will be equal to 42 times the number of jackets we buy, plus that one-time shipping fee, $9.25. And if we wanted to check, we could see that 42 times, in this case, 6, plus $9.25 will give us our grand total, $261.25. So to break down all those words, our solution is just 42 times the number of jackets plus your shipping fee gives us our total. And that's all we have for that example. The solution is D, given by that equation and our total. So that's the end of our presentation for today. Your assignment should be on the board. And we'll get started working on those problems so we can finish this section and move on to section 6 in our notes.